Transformers is one of the popular library from Hugging Face. We are going to look at what is this transformers and how it helps with our machine learning or AI related workflow. Like I said, transformers is a library from Hugging Face. What it does is it provides a unified interface for inference and fine-tuning of many state-of-the-art pre-trained NLP as well as LLM models. And with this, we can do many different things that includes classification, summarization, translation, and much more. Although this transformers library was initially introduced for transformer-based neural network architecture, it is not the case anymore. It supports other architectures, even a closed source libraries via API calls. But we have deep learning libraries like PyTorch and TensorFlow, right? Why can't we use them? What is the problem with using them directly? Well, the models developed using these lower level deep learning libraries like PyTorch and TensorFlow can have different APIs, and these APIs will be decided by the author of the model. There is no uniformity there. What Transformers does is it simplifies that. It provides a unified interface for many different models. So we'll be able to play with many different models in a unified and consistent manner, rather than understanding and learning different API differences across different authors and models. So just to repeat, the Transformers library is not a deep learning library on its own. It still uses one of the existing deep learning libraries like PyTorch, TensorFlow, or JAX, but it provides simplified interface for us to use that model for our use case. Okay. So for example, if you take one of the model like, Llama is published by Facebook, and we have another model, BERT, published by Google. These are using two different architecture, and these models will have different APIs. For example, one of the model is developed using PyTorch and the other model is developed using TensorFlow. Now, if we want to play with both of these models, then we need to have understanding of both TensorFlow as well as PyTorch, and we also need to understand the APIs provided by each of these models. But when we are using Hugging Face transformers for these models, we'll be using simple unified interface regardless of the API exposed by original model as well as the deep learning library they have used for developing this model. So how this works? How is it possible? Well, what will happen is when a model is open sourced, let's say for example, Llama is open sourced by Meta, Hugging Face contributors will redevelop that model architecture which is compatible with Transformers API. But they'll be using the original model weight and configuration. So the model architecture is replicated in a way that it is compatible with the Transformers but without compromising any of the quality. And once the model architecture is replicated, we'll be using the same weights and configuration provided by original model. So this is what Hugging Face contributors does for each of the models that are open sourced. So this way, we'll have the model architecture developed in a way that is compatible with transformers, but we'll still be using the original weights and configuration. This way, all the models supported by transformers will provide consistent interface for the consumers like us. Okay. Now let's move on to some of the core abstractions provided by Transformers library. The first one is pipeline. So this abstraction allows us to perform different tasks like text generation, sentiment analysis, image segmentation in a consistent way across different supported models. And similarly, we have another abstraction called generate, and this abstraction is very useful for text generation using various LLMs supported by transformers. And last but not the least is trainer abstraction. So with this trainer abstraction, we'll be able to train a model from scratch in a consistent and unified manner, and also we'll be able to fine-tune an existing model in a consistent and unified manner. Okay, so these are the three core abstractions provided by Transformers library. So just to show how much difference it makes when using Transformers pipeline abstraction for simple tasks like sentiment analysis compared to using the lower level library like PyTorch, I have prepared an example and I'm just going to show that to you. So this is an example of sentiment analysis using the pipeline abstraction from Hugging Face's Transformers library. If you see here, we are just importing pipeline from Transformers And then we are using this pipeline function to specify what is the task that we are performing and what is the model that we are going to use for that. So this has to be one of the models supported by transformers, by the way. Then we can optionally specify what framework that we are going to use behind the scene. By default, it will be PyTorch, but if you want to explicitly specify a particular framework or backend library, you should be able to specify that here. And this is going to give me a classifier. And with this classifier function, I'll be able to perform my sentiment analysis task. So I'm passing stock market is booming as a text, and it is going to classify whether this is actually positive or negative. But if I want to do the same without using pipeline abstraction, then this is what it is going to look like. I'm using the same model, but you can see that this is much more involved. We need to deal with some lower level aspects of PyTorch, and we have a lot more boilerplate code here, right? So this is what we are avoiding by using the abstractions provided by Transformers library. Okay, so Transformers is an open source library provided by Hugging Face, and you can install this by following the installation instructions that you see in the Hugging Face website. In this video, I just want to introduce you to this transformer library, but in the upcoming videos, we'll be looking at some of the things that we can do with this transformers library. Okay, that is all I wanted to cover in this video. I hope this is useful. Thank you.